We're now going to turn to the part of propositional logic that deals with if-thens, also sometimes known as conditional. The idea is an if-then statement. What comes after if is a condition for the then, or sometimes it's known as a hypothetical. That is, it's what would happen if something were the case. So notice that we spent some time when we were talking about predicate logic, looking at categorical propositions. That is, we looked at men, mortal, categories, and then we were using quantifiers. The all was a quantifier, some is a quantifier, and that's what made the rules of inferences work, those logical words. Well, in the case of conditional propositions or hypothetical propositions, it's the if-then that makes the inference work where it does work. So, for example, we have an if-then statement. If Socrates is a man, then Socrates is immortal, saying something very similar to what that categorical proposition, above all men are mortal, is saying. That is, all times when Socrates is a man, Socrates is mortal. That there's a connection between Socrates being a man and Socrates being mortal. Or think of the if-then statement. If hydrogen and oxygen are mixed, then water is formed. Something you learned in science as a little kid, that there's a connection between hydrogen and oxygen being mixed and water being formed. It tells you, does it tell you what happens if hydrogen and oxygen are mixed? No, but it tells you what happens if they are mixed. If Ashley is a mother, then Ashley is female. Does that imply that Ashley is female? And I picked Ashley on purpose because Ashley is a name that is used both for men and women in the United States, or at least it had been. Does that say Ashley is a female? No, it just said if Ashley is a mother, then Ashley is a female. That's true even if Ashley is a guy. And here's another one to think about. We're going to think about this a lot because if we use this particular example, we're going to remember which inferences using if-then are good and which aren't. That is, if the president is in the White House, then he is in Washington, D.C. The idea behind this conditional is that the White House is in Washington, D.C. So if the president's in the White House, he is in Washington, D.C. And notice all of these are asserting a connection between one proposition and another. It's telling us that all times that the first proposition is true are times when the second proposition is true, which is why some of these if-then inferences are going to be very similar, as I kind of told you when we were going through categorical propositions, predicate logic, that if-thens are going to be perfectly analogous, and we will see how that works. But let's understand a little bit about conditional, the terminology regarding if-then statements, and what we call that is an if-then is a conditional proposition, a hypothetical proposition, and let's go back to that first example. If Socrates is a man, then Socrates is mortal. Well, notice we have the first proposition, which is also known as the antecedent. Ante, the prefix that means before, so it's what comes before the then. Ante is prior. And then we have the second proposition in the conditional, which is known as the consequent. Familiar with the word consequences? What happens as a result of doing something else? Well, that's this second proposition is the consequence, and it follows as a result. So now the term, we have conditional propositions, which are if-then statements or hypothetical propositions. They have an antecedent, which is the first proposition, the one before the then, and the consequent the following one, the result, excuse me, the second proposition. And let's just go through again so we understand a few things about conditional, hypothetical propositions. If Socrates is a man, then Socrates is mortal. Does this imply that Socrates is a man? No. It just says if he's a man, then he's immortal. It could very well be that I'm talking about somebody's cat or dog named Socrates. And also notice it doesn't tell us anything about what happens if Socrates is not a man. Right? If Socrates is my friend's dog, that if Socrates is a man then is mortal, because I know that Socrates isn't a man, it doesn't tell me about whether Socrates is mortal or not. It only tells me about cases in which Socrates is a man. Think of another one. Sometimes students get very interested in this particular conditional. If you study, then you will get good grades. It's true in my course. If you guys study, you're going to get good grades. Does that imply that if you don't study, you will not get good grades? Well, what happens if you bribe your professors? You bribe me. You can get a good grade that way without studying. Think of a couple other ones. If my head is detached from my body, then I will die. That's true of me right now. My head's attached. I'm not dying. But it's true that if it was detached from my body, I would die. Same way, if Ashley's a mother, then Ashley is female. And if the president is in the White House, then he's in Washington, D.C. Now, let's look a little bit at the truth conditions. We're going to build up to getting the truth table, but we're going to see with regard to if-thens, we can make similar diagrams to the ones that we used in the case of the all inferences, the all are inferences. So let's think about a case. We're going to make P the proposition that the president is in the White House, Q the proposition that the president's in Washington, D.C. So then if P then Q is that if the president is in the White House, then the president is in Washington, D.C. Or all times when the president is in the White House are times when the president is in Washington, D.C. Now watch the diagram on the left again as it comes up. That is, in the circle, cases where P is true. In the bigger circle, the cases where Q is true. Right. So in trying to remember these, we're going to play a game. I think you guys, when you were younger, might have heard, the game, Where in the World is Carmen Sandiego? To help kids, it was a game that was used to help teach kids geography. Well, where in the world is the president is going to help us understand conditional propositions and their logic. So, in looking at it, if the president is in Washington, D.C., then, think of this one. If the president is in the White House, then the president is in Washington, D.C. Well, let's look at the diagram. Those are in that circle, all cases when the president is in, the president's in the White House. If he's in the White House, he's got to be in Washington, D.C. Because anybody who's in the White House has to be in Washington, D.C. So if it's true, if it's a case where the president is in the White House, he is in this circle, he's certainly in the Washington, D.C. circle. And now the question we're at, that's what the conditional proposition tells us, but it doesn't tell us where the president is. The president may be in the White House, may be in Washington, D.C. Well, if he's in the White House, he's certainly in Washington, D.C., but he may be somewhere else in Washington, D.C. Could be at McDonald's. President Clinton was known to spend a lot of time in McDonald's. Or the alternative is, as he was today, he was up here in New York, looking over the disaster area. So the conditional doesn't tell us where the president actually was. And in a minute, we're going to turn and look at the truth table for the conditionals. So let's take a look. Once again, we have the P, the Q, if the president is in Washington, D.C., it says in the White House, then he's in Washington, D.C.